What's up, guys? We're back, and we're solving another LeetCode. Today, we're moving on to the next section of the LeetCode roadmap. I haven't solved all of them, but we're gonna start getting into some backtracking. I did a lot of recursive tree stuff recently, so I'm hoping I can really hammer in this recursive brain with some backtracking, with some combinatorics. So we're starting with the first one, subsets. What this question is saying is, given an integer array num of unique elements, return all the possible subsets. So basically the power set of the main set. And it must not contain duplicate subsets and return in any order. Awesome. So I know there's a Python library that you can download that'll just, well, not download, but just import that'll just do this for you, but I'd imagine that's not what they're looking for, because you can do it without using that library, and it shows a lot more, I don't know, recursive intuition. But if you want to, you can do that, and it's called, I forget, but you can look it up, and there's one for combinations and one for permutations. You could just run that on nums and return that, and it would do it fine. But it's like using a sorting function when they want you to implement a sorting function, you know? It's called dot sort when the question is to sort this list. So it's kind of like that, so I'm not going to do it. But what I will do is bust out MS Paint, and let's dive right in. So we're given a list, like 1, 2, 3, and we want to make a list of lists where at each point we either add something or we don't add it. I guess this wouldn't be the order of that. We want to either add or not add. So let me just do this in the order it would be. So we start at 1, don't add it. 2, don't add it. 3, don't add it. 1, add it. 2, don't add it. 3, don't add it. Then 1, add it. 2, don't add it. Or 2, add it. 3, don't add it. Then add all of them. And then don't add the 1, add the 2, add the 3. I mean, I'm not doing it in order anymore, but you get the idea. For every number in the nums list, we need to make a subset candidate and choose to either add that number or not add that number. And I'm trying to see if I can write anything else out, but I don't think I can. That's kind of just the intuition. I know how subsets work. Either at every element, you either add it or don't add it to the element, to the thing. So let's dive into the code and see if I can figure this out. I think we want like an inner function here. Create, or I don't know, find subset. And what do I want to do with it? Do I want to send something in? I know we need subsets, all of them, and we have to return that at the end. And I know we want a subset, and that we want to add something or not add something to that subset. So maybe I need like an index. Because then I could do like subset dot append nums I. And then I could call this on the next one. I mean, let me think about this. I need to add it or not add it. And I need to do both of these things. So I can add it, the I. And go to the next one. Then I need a base case. What do I do with the base case? Add the subset, and then what? Clear it? Would this work? Because I would have my subset, I'd start it with nothing. And I'd go in, I would call this with 0, or would I call it with 0? Yeah, because these are indices. And then I would add nums, go to the next one, add it, go to the next one, add it, until it has exceeded the amount that I need, then append that to the candidate and clear it. So then, or maybe not clear it. Do I need to return? Do I need to set, I think I need to set I equal to 0. Because then I'd add it, and then I'd just reset all the counters to try again. Well, I'm also noticing a problem. I'm adding, but I'm not adding. You know, you catch my drift. Do I remove? So I can either call it on the next one with the new number, or I can remove it? What would this do? What would this do for me? So I'd start, I have 1, 2, 3. And I would call my helper. At 0. Which would append 1 to my subset and call it at 1, which would append 1 to my subset and call it at 2, which would, here we go. Then add 1, 2, 3, and at this point I would be 3, so then this would terminate. And let me see what this means for me. So it would go bang, 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 and it would terminate. So then I would append it. I would append this one. This would get appended. It would equal back to nothing. And I'd be back to f of 0. I don't know how I ever get past this the way I have this set up. What I want to do is I want to have like a tree structure, right? So like, I'll just draw it over here. I come in at f of 0, and I either don't add f of 0 or I add f of 0. And then I advance to f of 1, regardless of whether there's something in there. And then either don't add f of 1 or add f of 1. This is the don't add side, this is the add side. And then I would have f of 2, and I would either not add or add. You get the idea. So how do I actually do that? So I have my function. I have my I. I like the I because whether I add something to the subset or not doesn't change like counting how many things I have done or have not done. So I like this and I like this. I don't know about these. I like that one for sure. So I'm at this, so I can add it or I can not add it. I don't want to have to remove it, but I don't know if I do this before, does that like, what does this do? Because what, this is gonna go no, 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 and it's gonna be empty, and then it'll add that subset, and it'll pop up one level, and it'll actually add it, and then it'll go down. Wait, actually like this. So find something, it'll go no, 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 and then I'll get here. This will complete. Finally. It can't go down anymore. Wait, because it's here. I would add it. And then... how do I escape? How do I escape? Because I go boom, 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 boom. Eyes 3. Or 0, 1, 2, yeah. I don't want to do anything anymore. So I add this to my main subsets. And then do I return? Can I do that? And I go up one level. So then I actually get out of that level. And then I do add it. And at this other level, I is 2. This is I. Because I is 0 at the start. I is 1, 2, 3. Add it. Return out. So now I is 2 again. Then I add it. Then I actually append it. So now we're here. And then I call it again. I think. With the I is 3. Which would add the 3. This would get like processed. And then it returns. Then it'll be back at the 2. Okay, wait, no. Then I would be at the 2, and then this would finish. So I'll be at this one. I would return up here in my base case, and then this level here would finish. It would go back up here. I actually like this. I'm going to submit this. Okay. This is not bad. What the hell happened? So I'm immediately noticing I have 7 numbers in each. Which doesn't make too much sense to me. Because I start at 0. Now I just do 0, 0. So I wait until I has reached past this length, and then I pen the subset. But like if my I is 0, then it goes up to 1. I check, I don't do anything. It goes up to 2. I don't do anything. It goes to 3. Maybe I do something every time, actually, don't I? Because my I is 0. Then it calls again, I is 1. That calls again, I is 2. That calls again, I is 3. Then it adds my empty subset. Returns. So I is 2. I actually add that. Then I is 3. I go up here. I add that. I return. And then I move on with my life. But why? I don't have a single low. I have a single low number here. It's because I don't reset my subset. I don't think I should have to. Whoa. That's the same thing every time. Hey Patrick. Yo.
You right?
Alright guys, I'm back. I was chatting it up with my roommate, you know, we were chopping the shit, okay? And I realized my issue. I was adding something. I wrote this, I was deep in conversation with him, alright? And I wrote this line and I ran it. I was like, wow, that really was it. Cause not that I wasn't paying attention, I'm actually a multi-threaded machine, you know, so I can allocate a thread to solving the subset problem, and I can allocate another one to talking to my roommate. I can do both at the same time. It's not impossible. But I like add one and I add it to the subset, but I never actually remove it from the subset. So like in my drawing here, I like add one, I will add one to I equals 2, I equals 3. Okay. And then I hit the base case. I return out of that. So I return out of here. I actually add something. Then I go back into there and then I remove it. So start at the top, empty. Hit this, hit this, hit this, hit this. Down right here. Hit the base case. Add the subset. Return up to now I'm here. Add one. Now I'm here. Hit the base case. Return up. Or add one and I hit the base case here. Yeah. And then I remove it. Go up. Finish that. Then I go up another level. And then I add it. Boom. Go down. Explore the whole tree. But I'm running into a different issue. So I have it. So I print the subset. And in standard out, I'm getting all the subsets that I want. But in output, I'm not actually getting anything. And I've run into this like obscure issue. I don't like actually know why. But like sometimes I've run into this where like it doesn't like append the list, and I think you have to do dot copy. You have to like copy it. I don't really know. That I actually don't get. That's like a Python thing though. It's not actually that important. But like if you ever like have a thing where you're printing it out and like it's working, but like especially if it's like a list of a list, but if you're like trying to append it and it's not working, sometimes just try dot copy, and I believe that'll work. Nice. Looks like we got this pretty good. Alright, I'm satisfied with that. Until next time, goodbye.